specifically focus on one type of energy. It's called potential energy in general, but then I'm going to specialize on gravitational potential energy. So there's a broad category of potential energies. So let's go do that. So I'm going to start off with the definition. And the definition goes something like this. So the work stored due to changes in position. Right? So the work stored due to changes in position is called potential energy. So that's our definition, and it's very, very similar in behavior to kinetic energy. So I'm going to skip some of the things of what actually happens, of what does it look like. So let's draw a picture of this thing. Okay, so suppose a person lifts a box. What do we know? Well, what we know here is that I'm going to have a situation where it looks something like this. I'm going to have a surface, and on the surface, I'm going to put a box. So let's say that this is the box right here. Now, what I'm going to do in this situation, I'm going to lift this. So I need a person. Right? So this here is, this person changes the position of the box. Okay. And the way this person is going to do it here is that they're going to apply a force upwards like this. So now what happens? This person picks it up. And now what they're doing here is that they're now holding the box over their head. So then if I go like this, I'm seeing that this is the box right here. So in this case, they apply a force all the way up to this distance right here. Again, language. Here we go. The work done to lift the box does not disappear. But reappears / transfers as stored work. So what do I mean by that? Well, let's draw a picture. When I look at this thing, what actually changed the position of the box? What actually changed it was this amount of work, right? Somebody had to lift that, so that means that they had to do work to lift this thing. And what we're saying here is that when I look at this thing, that reappeared as stored work. transfers as stored work, but in this case, what are we calling the stored work? The change in potential energy. So that means here that this thing started like this because it had zero height change, and then we lifted it up. And it got to that height right here. So the work energy theorem says that I do this, I change the energy of the system, that work does not disappear, it reappears. It reappears as potential energy. So what we're going to do here is that I'm going to focus on one type of potential energy. So I want to focus on gravitational potential energy, and look, I'm going to write it GPE. And this means that it's the force of gravity times the height change, which I'll call D. So this is what I'm going to focus on gravitational potential energy. So let's visualize the work energy theorem with gravitational potential energy. So what we want to do here is that we want to visualize the work energy theorem in pictures for gravitational potential energy. So let's do that. So suppose, right, your car is taken to a mechanic. And is placed on a lift. Okay, here we go. So what does that mean here? Well, you could imagine that I have a lift. So let's say I have a lift here, and then I'm going to have a lift over here. And I need to compare two situations. So here's the ground. And then what I have here is that this is the lift right here. So you drive onto this lift right here. Okay, so let's look at this. So you got this car. And we'll say this is the yellow car. And then I have a second car, which is identical, but this car, oops, is green. So now what's going to happen? I'm going to take this car and I'm going to lift it up. So that means this thing is going to get lifted up so that it's now what? This height. Right? So it gets lifted up. And so now I have my car right here. So that means that the lift has to do what? Has to apply a force. And what's it going to do? Well, it's going to lift the car up this height. So I'm going to look at that car and I'm going to ask the question, you know what? I'm going to move this over a little bit. I need a little bit more space. Okay, so then I'm going to ask this question. Which car requires more work to lift? So now if I look at this green car, and what I'm going to do here is that I'm going to lift this all the way up, let's say, to right here. And when you look at this car, And you're going to say, well, of course, the one on the right is going to take more work. Even though I'm applying the same force, this guy was clearly what? Lifted over a bigger distance here. Now to lift this, they each have the same force of gravity. So if I play this game here, what does the work energy theorem says here? It says, well, in each of these cases, I applied the force of gravity to lift these cars, exactly the same. But what's different? Of course, the distance. That has a bigger distance. So clearly, this took less work. This one took more work. But remember, work and energy are one and the same thing. So that means here, what's another way of saying that took more work? Well, the change in gravitational potential here is smaller. It took less work. In this case, the change in gravitational potential is bigger. That took more work. So what do we say? We say this. This was what? This is easier to lift. I could either say small work, or I could say small gravitational potential energy. This guy was harder to lift. I could say work, or I could say what? A bigger change in gravitational potential energy.